All right, so this unit, we're going to start off with a little bit of review things from Algebra 1 and from this year also, and try to make sure that we are probably as good as possible at doing some distributions and some simplifying and some things like that, because we're going to be able to do this in several different aspects of what we do in Algebra 2, and if we have issues with it, it's going to create um, more issues moving forward, and it's going to really put us in a bad spot. So, we have to be able to do basically a lot of this is distributions. We have to be able to distribute things, but we're going to have, instead of just distributing one single thing, we're going to be distributing a set of parentheses that might have two or three things in it into another set of parentheses. We have to be organized, but we also have to understand the two main things that sometimes get lost in these things. When we're multiplying things together, such as 2x squared times 5x to the fifth, all right, 2x squared times 5x to the fifth. Numbers, you just multiply it like normal. 2 times 5 is 10. But exponents, you have to add them when you multiply them. And it's because if you think of it as real simple, x times x is x squared. All right, you can think of it as there's two x's, whatever the situation is, but it's x squared. It means x times x. In this situation right here, I have x squared, which is x times x, and I'm multiplying it by x to the fifth, which is x times x times x times x. Now, they're all multiplied together. So it doesn't matter what order I multiply things in or if I group them. So I can take all those parentheses off there because it's multiplying, not adding. If it was adding, this doesn't work. And then if I look at that, I'm multiplying 2x squared, so x times 5 more x's all multiplied together, and it gives me x to the 7th. That's why you add the exponents. Do you need to know that? No, but you have to understand that you add the exponents when this happens. In the other example, if I'm adding or subtracting things, first of all, they have to have the same exponent. I can't add an x squared plus an x to the third. All right, I can't do that. So I have to be able to understand that when I do this, it has to have the same exponent on my variable. Everything has to be identical. It has to be like terms. Everything's the same. The coefficient is just telling you how many of those things you have. So this right here is telling me I have 10x to the fourths. All right, there's 10 of them in a pile, lined up, whatever. I'm going to take away 17x to the fourth. Now there's not 17 there, there's 10 there. But if I take away more than I have, then I end up in the negative numbers. So 10 minus 17 is negative 7. All right. And again, the x to the fourth is just telling you what you're talking about. All right. So I'm talking about x to the fourth. So if I had 10 of them and I took 17 away, I have negative 7 of them. All right. You should use a calculator for all of these numbers to make sure that you're right. Do in your head, great, fine. But you use a calculator to make sure that you're doing it correctly, because doing negative numbers and stuff in your head, while you might be okay at it, eventually goes bad. And we don't want the eventually to be when we're actually getting graded on something, or we actually have to prove that we know how to do something. And that's the time that we do 2 minus negative 3 and get negative 1 instead of 5. All right. So we need to make sure that we're using a calculator when we're doing this stuff, especially if there's fractions, just to double check our work, whatever the situation is, so that we don't get the wrong answer.